Hey 6th graders, this is Lesson 5, Session 3 in your books. It starts on page 97, and today we are using the order of operations with expressions, aka math problems, that include exponents. And our try it problem here says, Puebla, Mexico has been known for its Talavera tiles since the 1500s. Today, artists in the United States use Talavera tiles on buildings and walkways. 3 stages of a pattern with tiles are shown below. How many tiles are needed to make a stage 40 of this pattern? So first we need to figure out what is the pattern. And you'll notice that all of them have the 4 in the corner. So that seems to be the standard. And then within the pattern, stage 1 has 1 tile. Stage 2 has a 2 by 2 pattern. Stage 3 has a 3 by 3 pattern. So following that, it stands to reason that stage 40 would still have the 4 tiles in the corner and then have a 40 by 40 pattern. So 40 by 40. Okay. And I know that you know that when we have an array, the shape with the neatly lined up columns and rows, when we have that array, all we have to do is multiply the sides there. So 3 by 3 is 9, 2 by 2 is 4. So 40 by 40 is going to be 40 by 40. Oop, that's messy. There we go. And that's going to be 16 with 2 zeros behind it, 1600. But we cannot forget our 4 corners. So we have 1604. That's how many tiles will be on stage 40 of that pattern. That's a lot of tiles. Alright, down here, let's see what it wanted us to do. In the model-it, the first model, there's 2 model-its. In the first model, it says you can write numerical expressions with exponents to represent the pattern. So what they've done here is they, instead of writing the 1 by 1 is 1 squared, but instead of doing the 2 by 2, you could write that as 2 squared. Instead of writing the 3 by 3, you could write that as 3 squared. Instead of writing the 4 by 4, you could write that as 4 squared. Instead of writing 40 by 40, you could write that as 40 squared. That's a terrible little 2. Squared. Oh, that's a nice little 2. It's cute. And then don't forget the plus 4. There we go. In the second model, now they've taken all of these different versions and they looked at what they have in common here, and they made it into an equation. So instead of doing 4 plus 3 squared, 4 plus 4 squared, they put 4 plus whatever stage you're on squared. So they've made it an equation where you can just plug in whatever stage you're on and then do the math. So just turn that into an expression there, an algebraic expression. So we are now on page 99. Let's analyze these modelets, shall we? Number 1 here, look at the first modelet. Jaden evaluated the expression 4 plus 3 squared by adding first to get 7 squared. Use the order of operation to explain Jordan's error. Well, let's put down the order of operations, shall we? I'll put it in big red letters. PEMDAS. Okay, and remember what PEMDAS stands for? The P stands for parentheses, E stands for exponents, MD stands for multiplication division. Those are inverse operations. They stay together. It's not multiplication then division, it's multiplication division. And same with addition, subtraction. Those are inverse operations. They stay together. So what Jaden did is he added first when he should have done the exponent first. So let's put that down here, typed up I'll make it a little bigger. Okay, so in the order of operations, you do exponents before you add. But Jaden, oops, spelled his name wrong. Sorry, Jaden. Jaden added first. You can't do that. No, you have to do the 3 squared before you add the 4. That's the whole point of order of operations. All right, now down for number 2, it says place parentheses in this expression, the same one that Jaden used, to make Jaden right. So we're going to change it. We're going to put some parentheses in here that make Jaden right. So 4 plus 3 squared. Well, we've got the exponent. We were supposed to do that first, but what comes before exponent? That's the parentheses, so anything inside the parentheses. So if we place the 4 plus 3 inside the parentheses, now that's the first thing we do, because parentheses come first, and then the squared will come after. Number 3, evaluate 4 plus n squared when n is 40. So we already kind of did this up there, didn't we? So 4 plus, and then it says n, but n is 40, so we just have to put 40 instead. Just plug it in. And so we have to do the exponent first, because, you know, that's how PEMDAS works. Do the exponent first. So this is 40 times 40. Which we already determined was 4 times 4 is 16. Put 2 zeros after it, 1600, and then we'll add the 4, so it is 1604. 1,604 tiles. Number 4. The expression 4 plus n squared represents adding 4, the 4 tiles, to a power. Now think about multiplying a power by 4 instead. Okay, so we've got 4 times n squared, and then we've got 4 times n squared. So 2 different ways that they've written it. So we're going to write these out now without exponents. So this one here, we'll put it in 2 different colors. Let's color code it. You know how much I love color coding. That one will be green. Okay, so this is 4 times, okay, we have to do this without exponents, we have to expand this out. N times n. There we go. Now let's do the other one in purple. So this one now, the exponent applies to the whole thing inside the parentheses, because it's got parentheses. You have to apply the squared to the whole thing. So this is now 4 times n times 4 times n, because I've got to square it out. Which you could also write that 4 times n, because remember, multiplication you can mix around. But, you know, whatever. Okay, and then B, for the same deal, says, should you think of 4n squared, I'm not going to use that color. I feel like that's going to be confusing if I'm color coding. So should you think of 4n squared as the first way? Ooh, go back to my color coding. As the first way? Or as the second way? Explain your reasoning. Well, this is the same thing as this. 4n squared is 4 times n, which is also 4 times n. There we go. So that's the first way. Number 5. Describe the order of operations you would use to evaluate 8 plus 4 times 3 squared. Okay. Let's look at it. With please excuse my dear Aunt Sally. If you ever get stuck, just write it out. That helps. Okay, so first thing is parentheses, and that's what's inside the parentheses. Not just do parentheses exist, but you do the stuff inside the parentheses. So inside the parentheses, we have 3 squared. So we have the exponent in the parentheses anyways. It's like doing double duty over there. Okay, so 3 squared, which is 3 times 3. 3 to the power of 2. So 3 times 3 equals 9. So this is actually 9. So now we've got 8 plus 4 times 9. Okay, so we did what's in the parentheses, which was the exponent. Now, what do we do first? The multiplication, division, or the addition, subtraction? I'll give you a hint. It's the thing that comes first in PEMDAS. So we're going to do the multiplication first, the 4 times the 9. You got to do that before you add the 8. 4 times 9 is 36. Now we can do the addition. 36 plus 8 equals 44. That sounds right. Yeah, 44. You could also answer this question. If you don't want to solve this question, you can. This says describe the order of operations. So you could also write out square the 3, then multiply the 4, then add 8. That would work too. Number 6. How do exponents fit into the order of operations? Let's see. They come after operations within parentheses. Can I spell parentheses? Parentheses. Is that right? Nope, it's not. Okay, wait. There we go. Parentheses. But before multiplication, division, and then addition. Oop, that's definitely not addition. Addition / subtraction. Okay, and then the reflect is for you to do. Think of all the things we went over in these last couple pages, and what was the part that you found the most understandable, the part that helped you understand the lesson the best. Pause, answer that question, and then unpause, and we will do 3 practices together. Okay, so page 100. Tamara is using rice paper to make Japanese lanterns. The expression 2 times s squared plus 40 times s represents the surface area of a lantern where the base edges, so down here the base edges are s inches long. In this drawing, this one looks a little shorter, but it's just because it goes back. If they both say s, then they're the same, which means the base is a square. Okay, what is the surface area of the lantern if s is 9? Okay, so we already have the height. The height is 10. And so, let's see. That means we need to find the area of all the sides, and because the base is a square, all the sides are going to be the same. So we really just, how many sides are there? There's 4 sides. So we're going to find the area of one side and, ooh, wait, we have an equation. What am I thinking? Just do the equation. You can find the area of each, but I'm crazy. I forgot we're doing equations today. Look at me. So we've got 2 times s, and it told us s is 9. So instead of the s, I'm going to put the 9, and that's squared, plus 40 times s, which is, why did I write s again? S is 9, because it told us. It said put 9 instead of s. So now we've got to use PEMDAS. I'll just write it on the lantern. PEMDAS. Okay, now remember when it says, when we start with P for PEMDAS, again, that means operations inside the parentheses. We have parentheses here, but there's no operations due inside. There's just a 9 in there, so we don't have to do that. We're going to do the exponent first, and the exponent is right here. It goes with that 9. So we've got to square the 9. 9 times 9 is 81. So this is now 2 times 81 plus 40 times 9. Okay, we did the exponent step. That's done. Now we're going to do the multiplication division step. There's multiplication right here and right here. Let's change colors just for fun. 2 times 81 is 162. 40 times 9 is, let's see, 9 times 4 is 36. And then there's a 0, so 360. So we did the multiplication division step. Now we're on the addition subtraction step, which is just that little addition left there. And 162 times 360 is 522. And it says we're working with inches. And those inches are squared because this is surface area, and area is counting the square inches. Okay. Number 9. What is the value of this expression? So once again, let's bust out our PEMDAS. And work through this expression. I'm going to write it a little bit bigger down here. 5 times 3 to the third minus 4. So first thing we have to do is the operations inside the parentheses. Inside the parentheses we have two operations. We have an exponent and we have subtraction. So within the parentheses we also have PEMDAS. What do we do first? The exponent or the subtraction? Let's see. Exponent, subtraction. Which one came first? The exponent came first. So we're going to do the 3 to the third, which means 3 times 3 times 3. There are 3 3's in this multiplication sentence. 3 times 3 is 9. 9 times 3 is 27. So now we've got 5 times 27 minus 4. Okay, so we still have parentheses here, so we're still doing operations within the parentheses, and that other operation is subtraction. So now we've got 5 times 27 minus 4 is 23. There we go. So now we've done what's in the parentheses, which was an exponent. Now we're doing multiplication division, which is what we've got going right here. This is 5 times 23. 5 times 23 is, well, let's see. I know that 5 times 20 is 100. 5 times 3 is 15. So that's going to be 115. 115. There we go. Number 10, last practice problem together, and then you've got your green pages. We have, what is the value of m plus 4n plus, or not plus, minus 5q plus 4, don't forget the plus 4, when m is 5, n is 2, and q is 3. So it's got all these variables in there, but it gave us the values already, so we can just write them in. Okay, the first one is m. m is 5 plus 4 times n squared. Okay, well n is now, I'm going to have to change colors. Yellow's too light. 2. There we go, use orange instead. Plus 5 times q, but q, it says put 3. There we go. And then don't forget this plus 4 at the end. Okay, so we've plugged in, we've taken these 3 variables, and we plugged in the values that they suggested for us. How nice of them. Now, back to PEMDAS. There are no operations to do inside of these parentheses, so that don't need to do. We need to do the exponents next, and there's only the one right there. So all we've got to do on this first round is 5 plus 4 times 2 squared. 2 squared is 2 times 2, which is 4, plus 5 times 3 plus 4. Okay, so we did the exponent step. Now we're on any multiplication division must become first. So all these additions. Oh wait, I was supposed to have a minus in here, huh? I'm gonna mess this whole thing up. That's supposed to be a subtraction. Dun, 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 dun. You're probably already yelling at the screen at me, aren't you? Okay, let's pick another color for this line. Okay, so we have to do the multiplication first. So this 5 isn't multiplying by anything, so it's going to come down. Here we've got multiplication. 4 times 4 is 16. Minus some more multiplication. 5 times 3 is 15. And then we'll bring down the other addition. Okay, so we finished all the multiplication and division. Now it's time to do the addition and subtraction. And we don't have to do all the addition first. Addition and subtraction are inverse operations, so they go together. We're just going to do them in order. Actually, yeah, we'll do them in order. Let's do them in order. Why not? 5 plus 16, that's 21. 21 minus 15. Let's do that over here. Just why not? 21 minus 15. That is 6. 6 plus 4. So this is 5 plus 16 is 21. Minus 15 is 6. Plus 4 is 10. Oh look. That's B. Hooray. Okie dokie. Thanks for watching. Bye.